allergy medicine is. Krish, what are you doing at my house at 4 a.m.? Never mind, you're just here to see me start my day off right, with a healthy peanut butter and jelly sandwich. Today would be great if it wasn't for one small problem. I can't find my allergy medication, and my allergies are messing. My allergies are messing with me. I keep sneezing and not using. Over. Wow. That must have been one forceful sneeze because I knocked that peanut butter jar all the way across the table. Notice how it slid instead of rolled. I wonder what would happen if it rolled. Fortunately, I probably won't be wondering for much longer because I'm probably going to sneeze again. Wow, look at that! Instead of sliding this time, the peanut butter jar rolled. I wonder what the difference between the motion and distance traveled that makes. Because assuming that the force of my sneeze was constant, there has to be some sort of difference. Let's find out. So, let's figure out why and how far and quickly exactly my sneeze knocked the jar of peanut butter. So, for the mass of the jar of peanut butter, we can do P equals the mass. For the acceleration, we can use A. Assuming this table is not completely smooth and has a coefficient of friction, we can make T the coefficient of friction. Coefficient T, K, the coefficient, the kinetic coefficient of friction. So, in order to calculate the force I exerted, we can use F to equal the force of the sneeze. I think that's all the variables we need.
After adding these two variables in, we finally have all the variables we need. So onto the formulas. So when we have the force of the sneeze, that's the initial force that we use to move the jar. So in order to calculate the net force, which we will represent by capital F sub n, we will say that that is the force of the sneeze minus the frictional force, which is represented by F sub F, which we can translate to the kinetic coefficient of friction times the weight of the jar. So then if we were to substitute this in here, it would be represented by this over here, this formula. So then, as we know, F of n is the mass of the jar times the acceleration of the jar. So in order to calculate the acceleration, we would substitute ma for the net force, and then acceleration would therefore be the net force formula divided by the mass. After finding out acceleration, you can now find out the final velocity of the jar. So then to find out the final velocity of the jar, you would take v final squared equals v initial squared plus 2as, s being the distance traveled, a being the acceleration. So we don't know v final, but we do know v initial, which was 0 in this case. Actually, wait. Alright, so v initial is indeed 0, so that'll just be 0 squared plus 2as. And 2as in this case would be represented by, we would substitute acceleration in. So that'll be 2 times force minus the coefficient times m times g over m, all multiplied by the distance traveled, which we can measure by just using a ruler or whatever. And then you just square root everything, and then that'll be your final velocity of the jar of peanut butter.
Yeah, it's rewind time.
Never mind. Okay, so what we do here is that we actually don't know s, so in order to find out s, we have our final velocity, and we already have all the variables here, so let's just head over to the next page. So let's just copy down this formula up here. So then it's vf squared is equal to 2 times f minus the coefficient times n times g over m multiplied by s. So we need to just get the formula for s. So in order to do that, we just do... So we divide both sides by 2 first off, so then this would be s times f minus this is equal to f squared over 2. Then s would just be multiplying each side by the reciprocal of the fraction in the parentheses. So then that would just be f squared over 2 multiplied by m over m plus k.
Epic victory royal.
So basically, this noodle looking thing represents my arm hitting the couch. This is the force that is exerted on the couch from my fist. So to restore itself back to the original position, the couch has to exert a force back on my fist. That's called the normal force. So when Gabe destroyed me in a game of Smash, I threw the controller in this kind of motion. So the initial velocity can be modeled by this vector right here, which can be broken into the y component and the x component. So you use these components for the displacement in each direction. For delta x, you have initial velocity in the x position, which is right here, times the time plus 1/2 at squared. For displacement in the y direction, you use initial velocity of the y times t plus 1/2 at squared. These formulas are the same, but what changes is gravity, as you can see when you plug it in here. For the x, you get delta x equals v initial in the x direction times time, because there's no forces acting on it in the x direction. Delta y becomes v initial y times t minus g over 2t squared, because the force acting on it at all times is gravity. That's with respect to this position, because the displacement would be negative from the gravity over time. Whee.